Hello guys, you are welcome to our class for today. This is Noble Mind Science Tutors Online and I remain Otobo Michael. Our class for today we are going to be looking at calculations involving graphs of motion. You know we have treated motion and we've also treated the graphs of motion. So we'll be looking at some calculations that are related to graphs of motion. So please, if you have not subscribed to this channel, kindly click on the subscribe button. Also click on the notification button so that when we upload a new video, YouTube will notify you. You can also add us up on this WhatsApp link, WhatsApp number, and then you can also reach us through that WhatsApp number. Okay, so for this class today, we're looking at calculations involving graphs of motion. So welcome to our class, and please get your writing materials and be ready for the class. Also, you can invite your friends to join in enjoying this physics class. So let's go straight to our class. Okay, so we'll be looking at velocity time graph, and normally for you to draw a velocity time graph, you need to have the values of the velocity on the vertical axis, and then you also have the different values of time on the horizontal axis. So for a typical velocity time graph, this is what you will have. This for a velocity time graph for a uniformly accelerated motion. This is a motion that starts from zero, that is from rest, and accelerates to this point. Now from this particular graph, there are different informations that you can deduce from this graph. The slope of this graph will give you the acceleration of this body. That is, acceleration is change in velocity all over change in time taken. So the slope of this graph will give you the acceleration of this body. So that is one of the deductions that you can get from this particular graph. Besides that too, you can also get the total distance traveled by calculating the area under the graph. The area under the graph will give you the total distance traveled by this body that is accelerating uniformly. So this is what I've said. The slope of this graph, change in velocity over change in time, will give you the acceleration of this body. And also, okay, this is exactly what I've said. Also, the area on this under this graph will give you the distance traveled by this body. All right. Acceleration, we know, is the increasing rate of change of velocity with time. So when this rate of change is constant, then the acceleration is said to be uniform. And that is what this equation explains. Change in velocity all over the change in time taken gives you the acceleration of the body, which is the slope of this particular graph that we have here. All right. Okay, so as I've said, the distance traveled will be the area under the graph. Now this graph is a triangle, right? And you know that the area of a triangle is equal to what? Half base times perpendicular height. So if you know the values from 0 to t2, which is the time, and this height, which is the maximum velocity, you can actually find the area under this graph. And that is what we'll be looking at in this particular topic. We'll be looking at calculations involving graphs of motion. All right. So this, what I've discussed so far, is just like a brief introduction to what we want to do today. Okay. So we have what is called combined velocity time graph. Combined velocity time graph. So this is how it looks like. This is a combined velocity time graph. This time graph tells you that a car accelerates uniformly from rest. It now attains a particular velocity. it maintains that velocity for a time t, and then the brakes are applied, and then it begins to decelerate down to within time 3, and it now comes to rest at f. So this type of graph is called a combined velocity time graph, and most of the questions that you are giving in physics that has to do with velocity time has to do with this type of combined velocity time graph. So we're going to solve problems on this using this particular type of graph, and then we see how to calculate the distance covered and then some other variables from this particular type of graph. Okay, so for this particular graph, these are some deductions or calculations that you can make from it. Now, these are different stages of the journey. The first stage is that the car accelerated from rest and gets to a maximum velocity v2. So in this particular case, initial velocity is 0, maximum velocity is v2. Now, to accelerate from 0 to v2, the time taken is t1. That is from 0 to g, the time is t1. So for you to calculate the distance traveled within this stage A, you will need to calculate the area under this graph, and this is the area of a triangle, which is half base times height. Half base times height. So for you to calculate the area here, it is half base times height because it's a triangle, and that is the distance covered within this stage A. Now in stage 2, you will see that the shape of this figure here is a rectangle, and the area of a rectangle is just length times breadth. So which means that the distance covered is the area of this rectangle, which is length times breadth. Okay, and within the time t2. Then in the deceleration stage, which is stage C, the area is like that of stage A, which is this is a triangle, so this is also half base times height. So by the time you add up all the areas of A, B, C, that will give you the total distance traveled. Now, if you look at this particular shape very closely, you will see that ODEF, the shape is that of a trapezium. So ordinarily, you can actually find the area of this shape by using the formula for the area of a trapezium. And you know that the area of a trapezium is equals to the sum of the parallel sides, half the sum of the parallel sides times the perpendicular height. Half the sum of parallel sides times the perpendicular height, which is half DE plus OF times DG. You can either use DG or EF as the case may be. So that gives you the area of the trapezium, and that is also equal to the total distance traveled. So you can actually use this formula in exam condition. You might not want to break it down this way, so you can actually use this formula to solve and then get your answer. It is the same answer you get here that you also have when you break it down step by step. So we're going to solve a problem to drive home this point that I have just discussed. I hope this is clear and simple for you to understand. Okay, so I want to solve a problem now to drive home this particular point. I want you to know before we go to the problem is that when the car is retarding, that is from E to F, this initial velocity becomes, this final velocity becomes the initial velocity here, and the final velocity at rest will be equals to 0, right? So when a body is retarding, the initial velocity is higher than the final velocity, and that is what I was trying to state here, that when the body starts from rest, initial velocity U is equals to 0. When it comes to rest, when it stops, the final velocity V is equals to 0. So having this point in mind, we'll now go straight to solve a problem to drive home this particular point that we have discussed. Right, so I want to look at the questions, then we'll see how we'll solve it to drive home the understanding of this particular point. Okay, so this is a sample question. A body starts from rest and accelerates at 3 meters per second for 4 seconds. Its velocity remains constant at the maximum value reached for 7 seconds, and it finally comes to rest with uniform retardation after 5 seconds. Find by graphical method A. The distance moved during each stage of the motion. B. The average velocity over the whole period. Alright, so we're going to draw the solve this problem. First of all, we must draw the graph to represent this particular question. We'll first of all draw the graph, then before we begin to solve for the distance covered during each stage of the journey. Okay, so please, you pardon me if my graph is not too straight, but you just pardon me, then we'll get something good. Alright, so solution for this. Say solution. First of all, you draw the graph to represent the information that is given to you. I'm sorry, please. Okay, so you draw the graph just like what we discussed initially. Please, you can draw your own so that your own will be very straight than mine. Okay, so let me do it again and see if I can get something that will be a little bit better than what I had initially. Okay, so try and draw your graph so that it can be straight. Okay, so we'll try to get the various stages of the journey. Okay, so we can take this as stage 1, stage 2, and then this can be stage 3, right? Okay, so that's stage 3. So the car starts from rest, so which means started from 0, and it attained this velocity v that we're going to calculate and solve for, and then velocity v. So this can actually describe the journey. Car starts from rest and accelerates at 3 meters per second for 4 seconds. So the first time we put it there, this is 4 seconds, right? Okay, put it there, 4 seconds. It maintains the journey for 7 seconds. Okay, so this is 7 seconds, and it finally came to rest at after 5 seconds. That is, retardation is for 5 seconds. So within this stage, this 5 seconds. Alright, so this is velocity as this, and then this is time as this. Okay, so this time as this. So please, as I said, you draw your own to make it very neat and fine. Now, having gotten this, the next thing you're going to do is for you to find the final velocity, because when the information that is given to you, you are giving acceleration and the time for the acceleration, but the final velocity is not given. Since the body started from rest, it means that u is equals to 0. So from this particular question, u is equals to 0, which is initial velocity. Initial velocity is equals to 0 meters per second. Final velocity is unknown. You do not know the final velocity, right? So since we don't know the final velocity, and we know that the acceleration is 3 meters and in 4 seconds, we can use the first equation of motion, which says v is equals to u plus at. This is the first equation of motion. We'll get to that in our other videos. So v is unknown, u is equals to 0. Substitute to that equation, we have 0 plus a, as we're giving to you to be a. A is given to you to be 3 meters per second squared, and the t is given to you to be what? 4 seconds. It's given to you to be 4 seconds. So substitute these values into the equation, substitute this into the equation. That gives you this. Alright, so you have 3 times 4. Alright, so V will be equals to, when you solve this out, you have 12 meters per second. So this 12 meters per second becomes the final velocity V that is here. This is the velocity that is maintained for this time before the car starts to decelerate. So having gotten this, we can now start to solve for the distance covered in each stage of the journey. Alright, so we've gotten the final velocity now, so we can now start to solve for the distance covered for each stage of the journey. So you can see that for stage 1, okay, so for stage 1, which I said before, the distance covered is the area under this graph. Okay, so the area under this graph, this is a triangle, so that gives you half base times height. The height now is the maximum velocity, which is what we have here. So for stage 1, you have a half base times height, which equals to half times your base is 4, that is 4 seconds, times your height, which is 12. Okay, so when you solve this out, you are going to have 2 times 12, because this will cancel this, so give you 2. So you have 2 times 12, which equals to 24 meters. Okay, so 24 meters is the distance for the stage 1. So you have gotten for stage 1, which is 24 meters. Okay, so for stage 2, in stage 2, we are looking at the area under this graph, and this is a rectangle. So for stage 2, it is just going to be the maximum velocity times time, because the height is 12 and then the time taken, which is the distance here, is 7 seconds, and that is the area of the rectangle. So straight up we have this stage 2 is length times breadth. So length times breadth, right? So that gives you length times breadth, and that gives you 7 times 12. When you multiply that out, you're gonna have 84 meters. Okay, so that is the distance for stage 2. Then for stage 3, we can actually see that this is not really too hard. For stage 3 is the same thing as like stage 1. So for stage 3, you are looking at this deceleration aspect. This deceleration aspect. So that gives us half 5 times 12. Okay, so 2 can cancel this. You have 6, and 6 times 5 is equals to 30. Alright, so this is it. So for each stage of the journey, for stage A, stage 1, the distance covered is 24 meters. Stage 2, distance covered is 84 meters, and stage 3, distance covered is equals to 30 meters. So this is the solution for the question A for this particular question. Okay, so I hope this is simple and you can easily relate to solving this problem. Alright, so then for the second one, the average velocity over the whole period. We know that average velocity is equals to the total velocity, right? You're going to divide it, average velocity is going to be the total distance traveled all over the time taken. Total distance traveled all over the time taken now. So which means that you are going to add up all these distances, then add up the time, divide the distances by the time. That will give you your average velocity. Okay, so when you add up this, you add up all the distances. If you add up all the distances, you are going to have okay, so average velocity will be equals to total distance, right? Total distance traveled all over total time taken, all over total time, all over total time. That's just it. Okay, so total distance traveled all over total time taken, and that gives you, if you add up the distances together, if you add up the distance together, you are going to have 138 all over the total time taken is equals to, add up 4 plus 7, 11 plus 5, 16. Okay, so that gives you 16. That gives you 16. Okay, so when you do that division, you have your average velocity to be equals to 8.6 meters. 8.6 meters per seconds. Okay, so I hope this is relatively simple, and or any question you have under this particular topic, this just has to go about it. This has to go about it. If you are not giving the final velocity, find the final velocity from the first equation of motion or any of the equations, depending on the information that you are given on the question. Then from there you can begin to solve for other variable that is requested of you. Is that okay? So this is how to go about solving questions on using the velocity time graph. I hope that is simple and is understood. Okay, so this is just the graph, and then right, so this is your own test page. You know, for every topic that I teach, I always give you questions for you to solve. So this is your test page. Please try and attempt these questions. They are past questions from WAEC. These two questions, they are past questions from WAEC. So try to attempt them, and then you can contact, or you can reach me through my WhatsApp link that is on the introduction page. Right from the introduction slide, you can reach me through that number, and then you can post your answers through also on the comment section. Is that okay? So try your hand on this, and then other questions that you can come across in past WAEC questions, just try your hands on them and then see how you understand this topic. Is that okay? So thank you very much. This is where I want to stop on this topic. I'll stop here on this particular video. So guys, if you have not subscribed to our channel, please try and subscribe. Click on the notification button, and then you can click on the bell too, so that when we upload a new video, YouTube will notify you. Please give us a thumbs up if you like what we are doing. We promise to continue to give you the best learning, Don't forget that learning now is no more reliant to your brick and wall classes. You can actually learn in the comfort of your home. So far you have your smartphones, your Android phones. You can learn. You can also invite your friends so that they can benefit from this learning experience. We promise to give you the best learning in physics as we progress in our lecture. So thank you so much. I'll see you in our next video.